Salutations Ape-Friends, my name is Owen Kirby and today I'm going to be teaching you how to play back MIDI files in TouchDesigner. Okay, so here's an example setup of what we're going to be ending up with. I mean, just this MIDI file. And how it plays back using these super synth components I've built. Okay, so that's a standard MIDI file I got off the internet in like a Super Nintendo MIDI file sort of file download zone. If you can recognize the song, then that's really cool. Okay, so let's have a look at a MIDI file. You'd think, geez, it should be pretty easy to play a MIDI file in TouchDesigner. After all, we do have this MIDI in chop device over here. Okay, and the first thing we're going to look at over here is in the source. In MIDI source, you have the option for file. So you think, man, geez, this is going to get me pretty close to playing my file there. Ooh, what's this? Okay, let's have a look at the file that pops out here. So we have, as you may know from a previous tutorial on how to build a MIDI sequencer, MIDI channels are named like this, as such. CH for channel, and then followed by the channel number, so 1 to 16, followed by the type of message, so C for controller, N for note, and the number of the controller or note. So here we already have a bunch of, CC's number 8, and a bunch of note number 60 on every single channel. So that's a weird file. Let's load that same Nintendo MIDI file and see what that looks like by default. So by default, same thing. We've only got note number 60 and CC number 8. So that's kind of wacky. That's not at all what we want. And we can notice when we look through the different parameters over here that there's a parameter named note scope, and it's set to 60. So the note scope is the scope of the notes that you want to be playing back in your chop. So by default it's 60, but that's not really helpful for any sort of musical application, which is typically what you'll be doing with MIDI. So you might be thinking, okay, I can just drop in a star in there and that'll give me all the notes, right? But the thing you should know before you do that is that it's going to create a single note for every single channel. So there's 127 notes times 16. So that's like thousands of channels. And it's pretty heavy on the viewer, and it's pretty heavy on the whole process. So I don't know about you. Here it is. You can notice it's already slowing down. We went into the MIDI component over here, and everything's just slowed down. So that's not super helpful. So wouldn't it be nice if we could only select the notes that actually have relevant information? So like in this file, there's not all the channels being used. So we don't want all the channels, and we only want the ones that are selected. So this is where we're going to get into building a script that's going to iterate through all the channels, figure out whether or not there's any sort of note information on there, and if there is, then select that channel and then pass it through using a select chop. Okay, we're going to go through a couple other options over here. By default, the note output is separate channels, which is how, as far as I'm concerned, it's how it should be. The other option is one multiplex channel. The difference here is that if you have one multiplex channel per MIDI channel, for the note information, the channel value will correspond to the note number, which means that you're not getting velocity information, only note, so note ons or note offs, only note value, and it's going to be monophonic by default because you can't have two values within one channel. So we're still keeping that on note separate channels, and velocity is going to be the amplitude of the note. Aftertouch here is left empty, but we're going to name it A because by default, the MIDI out chop also has default nomenclature for aftertouch and pressure and all this. And by default, aftertouch is A, and this is also polyphonic aftertouch, which is kind of less common, but that's polyphonic aftertouch. Pressure is going to be PR, pitch wheel it's going to be PW, and let's see, controller C, controller index 7, that's fine. Yep, and all this stuff, this is, we're going to get to maybe on another thing, but this is all the sort of machine control MIDI time clock stuff in the MIDI file. But right now we're just concerned with playing it back as best we can. Alright, so we're going to start by dropping a bass. We're going to call this one MIDI file player. Customize the component, MIDI file, add parameter. We're going to go in. So the basic setup is that we're going to try to find all the active, whoopsies, what am I thinking? We're going to try to find all the relevant note information and CC information in the file, use a select chop, and we're going to select the note names by way of a script, and then we're going to use a lookup chop and a ramp to sort of look up through that MIDI file and then send out the relevant information. Okay, a couple of notes on the way I like to do things over here. If I'm building components and I know that the input is around from 0 to 1, which it often is if you're doing any sort of sequencing, I like to color those ones yellow. And if the output of a component is a typical MIDI formatted messages, then I output those ones as dark blue. Okay, so MIDI in file. Now let's get a parameter execute over here. The operator is going to be its parent, dot for one level above, parameter MIDI file. Okay, so the first thing, when the MIDI file parameter changes, I wanted to, okay, let's set this up over here. I want the PW, I want this parameter to change to the file above, so we're going to do that. Operator MIDI in 1.r.file equals OP. Well, actually, I can do parent. Makes it a bit easier. Parent.r.midi file. So the first thing it's going to do is it's going to change this to the file that we want, and afterwards we're going to start our for loop. Or we're going to name our variables. Actually, we should do that before. Knowing that we're going to do a for loop, I equals 0. I is sort of just a typical number that, typical letter that people use when they're doing for loops. What else are we going to do? We're going to want a list equals empty list. We're going to end up turning the list into a string by using the join function. So we're going to do that with a empty space called p. And we're going to iterate through all the channels from 0 to the maximum number of channels. So max equals operator MIDI in 1.num chance. Okay. Now for I in range 0 to max, if operator MIDI in 1 is channel at the index of I, and if that channel is maximum value, so that's the max function in Python, doesn't equal 0, add that to the list. append is the function that allows you to grow a list and to add things to the list, so append. So within the brackets is where you write what's actually going on, what's being added to your function. So what's being added is the name of operator MIDI in one channel at the index of I. And once you've done that, once you've run through all the numbers, well, once you've done that for one number, you're going to want to increment I, so I equals I plus 1. And following that, once that's all done, you're going to want to send that list as a string to the select chop. So operator select one.r.chan names equals string p join function list. Okay, that we're gonna turn off the viewers because once you get a lot of channels, it starts to get a bit funky. In the lookup chop, make sure that you turn off the interpolate function if you want to get clean note ons or note offs, because otherwise you might get sort of in between functions from 0 and 1, and we're really dealing with essentially pulses here, so interpolate should be off. Okay, so let's see if this works. Now, I'm going to say right away that this isn't a real-time process, this like iterating through the list. Not a real-time process, however, it does enable you to format the MIDI file in a much lighter way, because using a lookup chop for hundreds of channels that you really don't need is not efficient, and it's not something you're going to be doing in a real-time system. So you're going to be loading up these files, maybe using this as a tool to format your files and to call all the needless information. Then you can always go back in and save the MIDI file as a chop channel itself, and then reuse that and then load that, and that must be a lot faster to work with. Whoa! That took a super long time, but there it is. It works. Let's plug in the lookup. Oh my goodness. Let's okay, let's bring the volume back up. Let's substitute this for that and see if we get the same results. Bring the volume back up. Okay. So that's it. That's how you play back a MIDI file. There's going to be more tutorials on this. Sort of tough to cover, but that's how you just get the notes out. And from there, there's a bunch of other stuff you can do. So hope you enjoyed this one. Have fun. Be good.